Assalamu alaikum. We know, according to quantum theory, radiations like light behaves as a wave at a region of lower energy, and they also behave as particle at a region of higher energy. This is known as dual nature of radiation. This wave particle duality of radiation is extended to matter particles by a French physicist Louis de Broglie in the year 1924. According to him, particles like electrons, protons, and neutrons, which are in motion, are associated with a wave. He named these waves as matter waves or de Broglie wave. In this, we will discuss about de Broglie wave or matter waves, and we'll obtain the expression for wavelength of a de Broglie wave. Before going ahead, let me tell you what is a wave. Wave is nothing but a disturbance in the space or a medium. It is specified by wavelength, frequency, velocity, intensity, and amplitude. These are some of the characteristics of a wave. When we talk about the particle or matter, a particle possesses parameters like mass, velocity, and momentum. Here, momentum is the product of mass and velocity. These are some of the parameters related with particle. Now, I will obtain the wavelength of matter waves. Now, as I told you, this concept of matter waves was given by a French physicist Louis de Broglie. Here, GL is silent. We pronounce this one as Broglie in 1924. Now, we'll obtain a wavelength of matter waves. To get the wavelength of matter waves, he equated Planck's equation and Einstein's equation of energy. What is that? First, I'll write Planck's equation. According to Max Planck, energy of the wave is directly proportional to frequency. It means as the frequency of the wave increases, energy of the wave will increase. Now here I remove this proportionality with the inclusion of equal to sign and a constant. I name this constant as h, which is nothing but a Planck's constant. Here the value of h, which is a Planck's constant, its value is 6.63 into 10 power minus 34 joules second. Now I take this is equation number 1. We know the energy mass relation was given by Einstein, and it is nothing but E is equal to mc square. It is taken as equation number 2. Now I relate equation 1 and equation 2. Comparing 1 and 2. See, in both equations, if you observe carefully, you may find that E is present on the left hand side. So this can be equated as mc square equals to h nu. Then I take this one as equation number 3. After that, let me relate these three parameters. of a wave. What are they? Velocity, frequency and wavelength of a wave are interrelated by an equation. What is that? T is the velocity of the radiation or a wave, which is the product of frequency and a wavelength. Here usually we use C to represent the velocity of light. So velocity is nothing but the product of frequency and a wavelength. So from this, frequency is equal to C upon lambda. I box this and it is named as equation number 4. Now I am going to substitute a 4 in 3. 4 in 3. What I will get if I do so? I will get this. mc square equals to h. In the place of nu, I write C upon lambda. Here, the C and this get cancelled. And we obtain mc equals to h upon lambda. Our aim is to get the expression for wavelength. So here I have lambda, which stands for wavelength. So I take this term to left hand side. So what I will get if I do so, I rearrange this. This can be drawn as lambda, and this term will come down to denominator. This is the expression of a wavelength. This gives us the wavelength of matter wave or de Broglie wave. If the particle travels with velocity v, then C can be written as C is replaced with v. So this equation will take a new form. Become lambda equals to h upon mv. Here we know very well the product of mass and velocity is nothing but momentum. So this can be written as lambda is equal to h upon p. Hence p is equal to mass multiplied with velocity. This is the final expression which provides us the expression for wavelength of matter waves. I hope the video is useful. If you have any kind of doubt related to the topic, then put your questions in the comment section. Thanks for watching.